So today what we'll be doing is we'll be taking a look at different types of triangles, and then what we're going to do is at the end of the day we're going to take a look at this thing called the Pythagorean theorem. You studied this last year. Now, the first shape that we're going to look for on a triangle is an isosceles triangle. An isosceles triangle has two sides and two angles which are equal. Just take a moment, copy that down, pause the video here if you want to. Continue. Now, the next type of triangle that we're looking at is a right triangle. A right triangle has a right angle in the corner. Now, one of the things that you should notice is that this equation, c squared equals a squared plus b squared, is the equation that links each of these C3 sides. C, A, and B. Now we can use that to find one side if we know the other two. And remember there's only one angle that is at 90 degrees. The next type of triangle that we're looking at is an equilateral triangle. One of the things that you should notice is that all three sides are equal. The next thing that you should realize is that all the angles are 60 degrees in each corner. The next type of triangle that we're looking at is called a scalene triangle. A scalene triangle means that none of the sides are equal, and all of the angles that we have here, this one, and this one, all add up to 180 degrees. So if I know two of the other angles, I can find the other one. Now, the next type of triangle that we're looking at is what we call an acute triangle. The acute triangle basically has no equal sides, but all of the angles are less than 90. The last triangle we're looking at is an obtuse triangle. An obtuse triangle is a triangle where it doesn't have anything, it doesn't necessarily deal with the sides, but what we're going to do is we're always going to look to see that one angle in the entire triangle is greater than 90 degrees, which means the other two are definitely less than 90. Because they have to equal, the total has to equal 180 degrees for each of these angles. X, Y, and Z. Now, take a moment, just copy that down, and we'll move on to the lesson for the day. Now, remember I told you that we were going to deal with the properties using the Pythagorean theorem. So, one of the things that you're going to realize is that with Pythagorean theorem, every triangle needs to be right angled, where C is the hypotenuse, A is the altitude, and B is the base. Or other way around. Some people call A and B the legs, and C just the hypotenuse. Now, the equation that relates them is C squared equals A squared plus B squared. Now, I want you to write these three main ideas down. When you have the Pythagorean theorem, you must have a right triangle. So remember, you have to have a 90-degree angle in one of the corners. You must have two sides in order to find the other side. And then, basically all we're looking for is to just find the third side. So let's take a look at example 1 here. Example 1 is 8, 10, and h, where h is the hypotenuse and 8 and 10 are the legs. So we start with our equation c squared equals a squared plus b squared. C is going to be h, 8 will be a, and b will be 10. Or you could have 10 and 8. It's up to you, your choice. So you have h squared is equal to 8 squared plus 10 squared. Now we simplify the right side, and we end up with 64 plus 100, and we keep going. So h squared is still 164, and in order to get h by itself, we have to square root, do the opposite. So now we end up with h is equal to the square root of 164, which gives us approximately 12.8 units. Now, if there are no units on the triangle, you can write the word units, or you could leave it as 12.8. The next problem we have is we have a triangle that's been turned around. Now, if you're not sure about the triangle, you could just turn the triangle upside down so that it looks similar to what we have for equation 1. And you'll notice that the only side that is missing, the side, is one of the legs. One of the legs. We have 6 and B and 10. So now what we're going to do is we're going to substitute directly in. We start with c squared equals a squared plus b squared, and we substitute. And we end up with, if we want to solve for A, we're literally going to have to take, for B, we're literally going to have to subtract A squared from both sides. And so you have C squared minus A squared equals B squared. Now when we continue with our calculation, we end up with 10 squared minus 36 squared equals B squared. Simplify, you have 100 minus 36. Which ends up being 64, which is b squared, and we can simplify that as b being the square root of 64, and the square root of 64 is 8. Now, that equation 1 is how you solve a hypotenuse. And example 2 is how you would solve for a side. So this would be finding a side. So what I want you to do now is I want you to copy down these 3 equations here and see if you can solve using these as examples. Now, pause the video, try them, and then take a look at my answers. Now, okay, here we go. You've paused, you've done the problems. Let's do these. So, if I have this for equation 3, we have 8 and 2 and x. X is the hypotenuse. So we start with c squared equals a squared plus b squared. We substitute. We substitute all that we know in here. So we have x squared equals a squared plus 2 squared. Simplify the right side with the exponents. So we have 64 plus 4. X squared is 68. And then what we're going to do is we're going to take x is equal to the square root of 68. And then we end up with x is equal to 8.2. Now let's do the same for example 4. So example 4 is again finding the hypotenuse. So we get something like this. So we have h squared equals 4 squared plus 3 squared. H squared is equal to 4 squared is 16 plus 9, 3 squared, which is 25. So h squared is 25. To get h by itself, we have to square root 25, and we end up with h is equal to 5. Our next set deals with example 5, which has one of the legs we're trying to solve. So we start with c squared equals a squared plus b squared, and then what we can do is we can substitute everything we need in here. So we get 4 is our c, x is our a, and 2 squared is our b. So now what we're going to do, in order to get x squared by itself, what we should do is we should do something like this. Simplify 4 and 2 squared. Now, what you can do is you're going to go and use what we did before. We want to get x squared by itself, so we're going to get rid of the 4 on the right side. So we can subtract 4 and subtract 4 here. The resultant equation is going to look something like this. 12 is equal to x squared, which means when I go and take the square root of x, we get the square root of 12 is x, and that gives us our final answer of 3.5. Your homework is going to be on the sum of squares on page 12 to 14 of your workbook. Amen.